is Electricity Part 2. You guys seem to really enjoy the last video, and thank you so much for your support. Let's get into today's video. Static electricity is the buildup of an electric charge on the surface of an object. It occurs when electrons, negatively charged particles, are transferred from one object to another, usually through friction, which we'll get to later on in the video. This creates an imbalance of charge, which can cause objects to attract or repel each other. Remember the law of electric charges from last video? Yeah, law 1 and 2 states that like charges repel and unlike charges attract. For example, when you rub a balloon against your hair, electrons move from the hair to the balloon. This makes the balloon negatively charged and your hair positively charged. Some electrons don't make it to the balloon, and these electrons want to get as far away as possible, causing your hair to stand up because like charges repel. Charging by friction. Charging by friction is when you rub two different materials together. Electrons will be transferred from one object to another. We can predict charges by using the electrostatic series. From our previous example, I said that the balloon would be negatively charged and the hair would be positively charged. If you look at the electrostatic series, you would see that the rubber balloon has a stronger tendency to gain electrons than the human hair. Meaning that it is more likely for the rubber balloon to become negative and the hair to become positive because it has a weaker tendency to gain electrons. Now, for example, let's take something that's super close together, like polyester and ebonite. You can see that both of these have a really strong tendency to gain electrons. But what's more important is that ebonite has a stronger tendency than polyester. So in most scenarios, if polyester becomes negative, in this one it becomes positive. It has a weaker tendency to gain electrons than ebonite. So polyester will be positive and ebonite will be negative. Charging by conduction. Charging by conduction / contact is when two objects with different amount of electric charges touch. The electrons keep moving between these objects until they have a similar charge. The charge is the same, positive or negative, as it moves. As you can see, this one has an overall net charge of positive 3, and this one has an overall net charge of positive 1. When these touch, the process begins. This one loses an electron, and this one gains an electron. So now, as you can see, charging by conduction / contact has occurred, and both of these have a valence charge of +2. Charging by induction. Charging by induction is when a charged object gets close to a neutral object. This causes a temporary charge to form in the neutral object. When you move the charged object away, the electrons go back to the original spots. As you can see in this diagram, the balloon is negatively charged and the wall is neutral. The electrons in the balloon are attracted to the protons in the wall, but the electrons in the wall are being repelled. As you can see here, there's almost like a natural shape of where the balloon is. You can almost tell, you can see the curve in the wall, similar to the curve in the balloon. So as you can see, these electrons are being repelled, and actually, the balloon is slightly attracted to the wall because of these positive electrons. But the thing is, if you ground the neutral object when you're charging by induction, the object can become permanently charged. So as I explained in the last example, as soon as you move the balloon away, the electrons went back to the original spots. But when a charged object is removed, the electrons from the neutral object can't return to their original spots. So as you can see in this one has an overall net charge of -3, and this is neutral with a net charge of 0. When you bring these two objects close to each other, the charge by induction begins, and the electrons in this object will repel, and this will slightly be attracted to this object because of the protons. Now, if you ground the neutral object, by the way, this is the ground symbol, you ground the neutral object, the electrons can get as far away as possible. So they go down here. And when that gets taken away, the electrons can't return to their original position because they've been grounded. So now that means that this has a permanent charge, a charge that can never come back. That is a positive charge of 5 in this situation. That'll be all for today. Thank you for watching. If you enjoyed this video, please consider subscribing. I would really appreciate it. Feel free to comment what you want to learn next. And don't forget to drop a like for part 3. Thank you.